Hey guys, in this video I'm going to be showing you how to create a circuit that includes a thermistor, an NTC thermistor. So the materials that you're going to need are all laid out right here. You're going to need a 9-volt battery with a snap-on clip, a Uno R3 controller board, some jumper wires, a 1000 ohm resistor, a blue LED, a red LED, and of course, your NTC thermistor. For your two LEDs, as long as they're two different colors, that's completely fine on there, which is what you're going to need to differentiate. You wouldn't want two of the same LEDs because, again, for this whole entire program, you're of course going to need to program with Arduino, which is also why you're going to need this USB cable. That way you can get plugged into your R3 controller board for the actual program itself. In this video, I'm not going to show you how to I'm not going to show you a step-by-step on what you need to do to create the program. I'm going to be linking that into the description below, so you can go ahead and look at that, program it onto your Arduino board, like I had done mine as a setup for this whole entire example. And yeah, let's go ahead and jump right into it. So the first thing I'm going to do is I'm going to take my thermistor and place it onto my actual board. Let me go ahead and zoom in for y'all. That's my actual NTC thermistor. Next thing I'm going to do is I'm going to take my 10,000 ohm resistor. I'm going to place it 1 unit down from the thermistor, and I'm going to go ahead and place it onto my breadboard right here. Like so. Notice how they're both connecting right here. That's what you're going to need onto your actual circuit. Next thing I'm going to do is I'm going to go ahead and take my blue LED and I'm going to place it onto the breadboard. And same thing with the red LED to have some sort of spacing. Notice though how I'm placing it on here. The longer part of the LED, the anode, is going to be pointing away from the actual thermistor. Like so. The reason why is because obviously if you place it the incorrect way, current can't flow naturally and your LEDs won't turn on. Same thing with your blue one. Make sure that your anode is facing away from your thermistor. Otherwise, it won't work. Next thing I'm going to do is I'm going to actually use the jumper wires in order to connect it. So from this first thermistor, starting from this point, I'm going to go down vertically, placing it all the way at the end, kind of crossing that bridge on here from the breadboard, and placing it onto my actual R3 controller board. I'm going to place that on the 5 volts right there. That's where the voltage is going to start, starting from this thermistor. I'm going to take my next jumper wire, starting at the end right here of the 1000 ohm resistor, placing that onto ground, like so. This red jumper wire connecting all the way down right here. And of course, one of the most important things is connecting this jumper wire that is in connection with these two, the thermistor as well as the 10,000 ohm resistor, all the way straight down, putting that jumper wire onto A0. like so. Now, the reason why I'm putting it onto A0 is because onto my program, I had referred back to A0 on here. Of course, I could have put it on any other type of input pin. I could put it on A1, A2, A3, A4, or A5. I just chose A0. Make sure that whenever you're looking over the program, notice how if I would have chose a different reference point, like if I put it onto A0, but instead in the program, I said A2, the program is still going to be fully functional. It's just that whenever the current or the voltage is going to be sent in to this circuit, the LEDs won't turn on because they don't recognize, or there's nothing that's being output onto the A2 pin, the analog pin. Next I'm going to do is I'm going to go ahead and connect these two LEDs together. Starting from this top one, this LED. And this blue LED like so. Next, I'm going to take this green jumper wire that I had chosen. Again, the colors don't matter, just as long as you have the jumper wires connected to the appropriate slots. That's completely good. To ground. Like so. Next, two important things again, because you're also going to be, if you look at the program that I had used, I'm referring to both the 9 and 8 pin respectively. 9 pin, of course, being to my red LED on there. And last but not least, this jumper wire placement over here for this LED all the way to the 8th pin on my board. So overall, this is what your circuit should be looking like. And of course, it's still not complete yet because of course we had to plug in our actual battery. I had preset this onto 70 degrees Fahrenheit on here. And essentially what should happen is that once I plug this in, this blue light is going to be on. And then of course with added heat, this red LED will turn on. So I'm going to go ahead and plug in my battery. And of course, as it should, the blue LED light has turned on successfully. And when I rub or use my two fingers, rub it against this thermistor, adding heat on here would actually give it less resistance in the thermistor. And because of that increased heat and lower resistance, instead of the actual current going to the blue LED, it's going to the red. As you can see, for just a moment, the red LED has turned on. Of course, I would have to maintain greater than or equal to 70 degrees Fahrenheit in order for this red LED to be turned on. But overall, pretty successful. So that's how this whole entire thing is working. So again, a full in-depth analysis of what is happening. So first off, this yellow jumper wire that's connected to the 5 volts, it's being placed into this NTC thermistor. Notice how I keep saying NTC thermistor. The reason why is because this whole transistor gives us a negative temperature constant Unlike the PTC, which gives me a positive temperature constant, this is the one that we're using. The main differences in them is that the NTC deals with a inversely proportional to resistance and temperature, whereas the PTC deals with the proportional resistance and temperature, which is why, because I have an increase in temperature, there's lower resistance, which is why it's going to the red LED. Whereas because of a much cooler temperature, there's going to be high resistance on here. So then probably asking, well, if there's such a high resistance, then why is it still going to the blue LED? Reason of that is because since these two are in parallel, kind of chooses which one because of this blue jumper wire being connected to these two. The red one isn't all that active in there, actually. The reason, of course, being this 10 ohm resistor playing a key role in there, which is why whenever the whole entire current flowing from this 5 volt to this thermistor to this 10,000 ohm resistor to the blue LED, because this is pretty much the only path that it's able to take right now. This is why the blue LED is turned on. That's like the standard type of resistance when it goes through the whole entire circuit. Whereas whenever I start applying heat, now the current has another option. It can choose the actual red LED. So instead of it going to the blue, it chooses the red. And then of course from the red, it goes back into ground. And then the whole process continues. It's a constant where the only variable that's changing is temperature. And that's how this whole entire circuit works. I hope you found this video helpful. Again, I'll be linking into the description below the Arduino programming for this whole entire circuit. Give this video a thumbs up if you thought that you've learned something, and I'll see you guys in the next video.